Hi, good morning, everybody, and welcome to this session on Conflux 101. I am Gloria. I am from Gitcoin, and I will be your host for today. Before we get started, I just wanted to go over a little bit of housekeeping. Please feel free to introduce yourself in the chat, your name, what you are working on, as well as where you are watching from, and that would be great. There's also a Q&A section. There's also a Q&A section if you do have questions, so you can put it on the chat or you can put it in the Q&A. If it's in the Q&A, we will go ahead and upvote the questions, and I will be monitoring the chat throughout this whole session, so feel free to do that. And other than that, we're going to kick it off with going over to Peter. Peter is from Conflux. And if you do have to leave early for some reason, this session is being recorded, so you can always go to our YouTube channel and watch the session there. All right, Peter, feel free to take it away.
All right, sounds great. Thank you, Gloria, for the introduction. And yeah, welcome, everyone. I'm very happy that you join us. Good morning, good afternoon, good evening, depending on your time zone. As for myself, I'm calling in from Shanghai, so it's 10 p.m. over here. Yeah, so my name is Peter. I'm a core developer at Conflux, which means that I've been working on the main blockchain client, so the client that actually executes consensus, does all the block creation, transaction, broadcasting, that kind of stuff. But I've also been getting more and more involved in community projects. I'd like to help out. If you have any cool ideas, if you have any ideas that you'd like to implement on Conflux, then I'd be very glad to help out. So today I'd like to give you a short intro to what Conflux is and what are the developer tools that you'd like to use when you develop on Conflux, and what are the resources that you can check out to learn more. But I think we can make it interactive. So if at any point something is not clear or you have any questions or any other topics that you'd like me to cover, then feel free to just post your question in the chat. Or maybe you can also raise your hand if you want to open your mic. But anyway, just let me know. So let's get started. Hopefully you can also see my screen. Yeah, so you're all familiar with the OpenDeFi Hackathon page. We have a number of very interesting bounties. And as for Conflux, we offer a stablecoin bounty, which looks very challenging, but I think it's also very exciting. So hopefully some of you will decide to join. And if you want to get started with Conflux, I'd like to encourage you to first check out this description because it has some pointers to other resources. First of all, if you have any questions, the first thing you should do is to join our Discord channel. You can directly ask me questions there or ask the community questions there. So that should resolve most of your issues. There's also this link, Conflux Tools, which is basically a collection of useful information and links that you can check out. So it has a short intro about Conflux. It has links to some of the topics that I will cover today. So the Conflux Portal, which is a wallet, Conflux Studio, which is an IDE, basically all the other stuff that you would need to get started. And the other link that's very useful here is the developer documents. So there's a somewhat more detailed, developer portal. Well, this is our official website, and the developer section has a bunch of cool stuff, but most importantly, the developer portal. So this is developer.confluxchain.org, and it has an intro about Conflux, information about running a node, sending transactions, SDKs, and also even more like technical APIs. So this should be your go-to reference when you do stuff on Conflux. All right. So for those of you who haven't heard about Conflux, I just give a short intro before jumping into all of these. So first of all, Conflux is a standalone blockchain. So we're not a DeFi project. We're not a layer 2. We're layer 1 proof of work blockchain. So it's a full-fledged, basically smart contract platform. And we have a bunch of cool features that might, make you want to check Conflux out. First of all, Conflux is very fast. So we have thousands of transactions per second. And what's cool about this is that we can achieve this without sacrificing decentralization. So you might have heard about this scalability trilemma a few years back. The main idea of Conflux was born at that time, and the idea was that yes, sure, there is a trade-off between safety, scalability, and decentralization, but we are far from reaching this the hardware limits that would really force us to make this trade-off. So we really pushed out the implementation, especially the consensus algorithm, not just the implementation, but the algorithm itself, so that we can actually achieve much higher TPS while also having like thousands of nodes all around the globe, mining new blocks and that kind of stuff. So it's a high scalability while also decentralized. So it's kind of the main idea, but also there's some details that will help you get started much quicker. So first of all, Conflux is EVM compatible. So our virtual machine, the Conflux virtual machine, is very, very similar to the Ethereum virtual machine, which to you, it means that for most smart contracts, there's no difference. So if you already have a smart contract on Ethereum, usually you can redeploy it on Conflux without any modifications. So the main difference is that some of the node APIs might be different. So if you call some RPCs, that kind of stuff, you might see some differences. But on the contract side, I've been working on moving some projects from Ethereum to Conflux, or like redeploying on Conflux, and usually no changes are necessary. So that's very helpful. So if you already work with Ethereum before, that means that you don't need to relearn all the stack, because you can use Solidity, you can use Conflux Truffle, which is basically the same as Truffle, the developer suites or developer toolkits with some minor modifications to just help you get started on Conflux. And basically, a big portion of the tools should be directly applicable to Conflux, so Ethereum tools. So that's very useful. So this is, at this point, Solidity compatible. And another thing that I briefly covered today is this transaction sponsorship, which basically means it makes it easier for your users to do the onboarding. So I think it's kind of challenging for blockchain that new users don't have any tokens when they create a wallet. So first they need to acquire tokens, somehow go to an exchange, purchase, but it's kind of a high entry barrier for most everyday users. Now on Conflux, you can come up with new business models that will allow you to actually sponsor the transactions for your users. So it means that you would pay for your users' transaction fees, and for them it's going to be free. They can interact with your DApp even without having any CFX token, which is our native token. Of course, this might require you to, well, either initially you might get some funding from the foundation for very high value or very interesting applications. You might get some funding, but also you might need to come up with novel business models that might be able to continuously cover transaction fees for new users by taking this off from some other revenue streams. So this is definitely very interesting for dApps, and also there's a built-in staking mechanism. So on the protocol level, if you don't use your CFX, you can stake it, or you can lock it for a certain amount of time, and then you can participate in governance. This time, for time limitation, I won't go into too much details about this. All right, so just a reminder, if you have any questions, then feel free to post it into the chat. All right, so first of all, I'd like to just show you the main tools that you will use to interact with Conflux. First of all, the wallet. So you see here I have MetaMask. And for Conflux, the wallet that you should use is called Conflux Portal. So if you use MetaMask, Conflux Portal should be very familiar because it's basically the same idea, the same user experience. It's a browser extension wallet, and you locally generate a seed phrase, and it uses the seed phrase to generate a number of accounts for you. So to get started with this, you can navigate to portal.confluxchain.org, and then you can just install it on Chrome. I'm using it on Brave. You can also use it on Firefox. I won't walk you through the process, but it's very easy. You just note down the seed phrase, and then you're good to go. So Conflux Portal basically works as you would expect. Let me see if I can change the view. So first of all, we have the mainnet connection, which is called Tethys. That is the name of our mainnet, or you can switch to a testnet, which you would probably use more for your development. And then you have a number of accounts. So if I want to have 2 test accounts, I also can add the new account here. I can give accounts a name. It's really very similar user experience to Ethereum. So if you're working on a testnet, to cover your transaction fees, you always need some tokens, right? So you see here in this account, I already have some tokens, but how can you get tokens for a new account? Well, it's very, very simple because we have a mechanism for this within Conflux portal. You just click on deposit, and then there's this get CFX button. You just click on it, and it will give you 100 test CFX on the testnet. So this is one of the ways that you can use Conflux portal to get test CFX. And then after a few moments, it will just show up in this new account. And apart from this, like sending, receiving is pretty straightforward. You see the CFX showed up here. So sending between accounts, when I click on send, it actually gives me the option to transfer between my accounts. So if you have, let's say, 2 deployer accounts or 2 testing accounts, you can also use this mechanism to transfer between. So I'm going to transfer from account 1 to account 2. Let's say 50 CFX. And this will just create a new transaction, send it to the network. And then after a few seconds, it usually gets processed. So by the way, when I talk about Conflux being fast, there's 2 parts of this. One is the TPS, so how many transactions we can process per second, which is on the magnitude of thousands. And the other thing is confirmation. So confirmation, for instance, for Bitcoin, you might need 10 minutes to get into the next block if you're lucky. You might need to wait for an hour, like 6 blocks, to consider a transaction irreversible, right? So in Conflux, this is generally, it depends whether there's an attack, a liveness attack going on, which we haven't had so far, but our consensus mechanism is equipped to handle these attacks. But normally transactions are confirmed within half a minute. And also usually even after a few seconds, they are already executed. So you see here it's executed and it's already confirmed. So I think that's basically all there is to say about Conflux portal. So that is basically the user perspective, how you interact with your wallet, how you interact with the CFX token. And the other perspective is that if you create a dApp, then you will actually make API calls to portal. So that's also very familiar to MetaMask. Let's say you have a front end with React, and at some point the user wants to send a transaction. Then you call the API, the injected provider API of Conflux portal, and it will just pop up a transaction confirmation panel, and the user can confirm the transaction. If you go to the developer portal that I showed you just now, it actually links to the Conflux portal documentation. And I won't go into too many details now, but it will basically tell you which methods to call to actually trigger transactions. So yeah, no surprises here. So that was the wallet. There's also a number of other wallets available, but basically Conflux portal is the official wallet. That's the wallet that most of our users use at this point. So I would recommend you to get started with this. Okay, the other thing that you might want to know is the blockchain explorer. So how can you actually see the data on the blockchain? And the Conflux blockchain explorer is called the Conflux scan. Just open it real quick. Yeah, for instance, here I have a transaction, right? If I click on the transaction, then I can directly go to the transaction page on Conflux scan. So the website is confluxscan.io. And it has a testnet prefix if you're on a testnet, or you can switch to the mainnet here in the top right corner. And if you ever used services like Etherscan, then this should be very familiar to you. This is basically your interface to see all the blocks and all the transactions on Conflux. Yeah. So before we go into this, I'd like to just give you a few remarks about how the consensus mechanism of Conflux works. So for getting started, I really encourage you to go to this developer portal and learn the basics about Conflux here. We have a very short overview of the basic ideas behind Conflux, and also some other information about some of the new things about Conflux if you're coming from Ethereum, especially. So the way we achieve high TPS is by introducing a novel ledger format. So we don't use sharding. We use a DAG, a decentralized acyclic graph, which is a very loaded term to be honest. But for us, the main idea is very simple. We have blocks. Blocks have a number of transactions, and blocks form this DAG structure. By this DAG structure, I mean that each block has two kinds of references. One is the parent edge. So this is the solid edge on this figure. And each block references exactly one parent. So that's the same as, let's say, Bitcoin and Ethereum. But the other one is another kind of edge, which we call the reference edge. And one block might have 0 or 1 or more reference edges. And this basically gives us extra information between the relation between these blocks, let's say D and E. We have some timing information if E references D. But without going into too many details, this allows us to use all the blocks that has been created. So in many networks, let's say Bitcoin, you might have some blocks created at the same time, like concurrent blocks, but you can only keep one of them, and all the rest will be discarded. So these are called orphans. Now in Conflux, using the so-called tree graph data structure, which is this DAG, and using some novel consensus considerations or algorithm, we can actually use all the blocks that are available. So of course, it's probably easy to see that would contribute to the TPS of the system. So instead of just transactions from one block, we have transactions from 3 blocks, so there's more transactions. Yeah. So you might ask, why is it called a tree graph? Well, it's because this graph, you can call it a DAG, but it actually has two perspectives. If you only look at the parent edges, so you disregard these reference edges, the dashed edges. So the parent edges form a tree in terms of the graph theoretical notion, which is similar to other blockchains. So Bitcoin is actually not a chain. Bitcoin is also a tree. You just choose a single chain from the tree. But if you look at all the edges, then it actually forms a DAG, which we call a graph here. So that's the idea behind the tree graph. This term is that there are 2 different perspectives on this data structure. If you want to learn more about how this actually works, there's a webinar series on our YouTube channel. So if on YouTube you search for Conflux Foundation, it's a series of like 10 3-minute videos where I walk through step by step how blocks are created, how the ledger is interpreted, how the blocks are ordered, how transactions are executed, all these details. So if you want to learn more, just take a look at that. Why I brought this up now, because when you develop dApps, you don't really need to understand all these details, to be honest. But there's one concept that I'd like you to understand, which is the concept of the epoch. So in Ethereum, when you want to reference a block, you can of course use the block hash. So the block hash is always a unique identifier for the block, but you often use the block number, which is the serial number of the block in the linear sequence of the blocks, right? And in Conflux, it's somewhat different because we use a deterministic mechanism to divide this tree graph into so-called epochs. So an epoch can have 1 block, or it can have more than 1 blocks. Usually it's like 2 or 1 to 5 blocks. Sometimes it might be larger, but that is basically the corresponding notion to block number in other systems. And the reason you need to know this is that most of the APIs of Conflux use the epoch number instead of the block number. So in this figure, you can have epoch number 1, 2, 3, 4, 5. So it's basically just an incrementing number. It's easy to understand. Or you can also reference an epoch by these blue blocks, which is called a pivot block. So you can reference an epoch by a hash, or you can reference it by a number. So if you go back to Conflux scan, you can actually see that I have the sequence of blocks here, and there's an epoch number here on the left. And for instance, here, this 50 suffix epoch, it actually has 2 blocks. So both of these blocks belong to the same epoch. If I click on the epoch number, I can actually see a list of the blocks. So you can see there's 2 blocks. One of them is the pivot block. It's not very important for our session now. And then of course you can identify the blocks by the hash. So if I open the block page, I can see all the information about the block. So for instance, I have 3 transactions in this block. I can see the miner of the block, I can see the block reward, etc. So that's all very intuitive. Another thing that might, that you might come across, which is kind of new to you, especially if you come from Ethereum, is that the Conflux addresses look very different from Ethereum addresses. So in Ethereum, of course, it's a hex string. It starts with a 0x. Usually it's displayed in that way. On Conflux, we chose to change the address so that it's harder to mix it up with Ethereum, especially because we have a cross-chain mechanism where you can move assets from Ethereum to Conflux or the other way around. So if we use the same address mechanism or address format, it would be super easy to mix these up and accidentally lose funds. So instead, we have this very easy to recognize address. So on the testnet, addresses start with this CFX test prefix, and on the mainnet, they start with the CFX prefix. So it's just looking at the address, you can see that it's a Conflux address. So that's very useful. And if I open this address, I can see the account information. So this miner has 6 million CFX balance. I can actually query other tokens if they have. And I can see all the transactions sent by this account. So this is all pretty intuitive, especially if you used other blockchain explorers. Yeah, welcome to all the newly joined people. If you have any questions, just feel free to send it to the chat. If you go to the tokens here, you can actually see, let me switch to the mainnet. You can actually see some of the commonly used tokens deployed on Conflux. So for instance, FC Fanscoin is one of our oldest tokens. It was actually created before the mainnet launch and then migrated onto the mainnet for incentivizing the community. And for the cross-chain stuff, you actually have Conflux tokens for a lot of assets from other chains. For instance, for Ethereum, you have one-to-one correspondence between ETH on Ethereum and CETH on Conflux. So this is the Ethereum tokens mapped onto Conflux. And you can see that same with USDT and a bunch of different tokens. So I briefly show you this mechanism at the end, this cross-chain mechanism. But for you, what's interesting is that you can actually make use of all these assets if you build on Conflux. You're not limited by the assets available on Conflux because you can just move assets from Ethereum, from BSC, even from BTC, and we're working on adding more and more chains. And if you open the contracts page, you can see some more information about the contracts. So this is the token page, sorry. And if you open the contract, for some contracts, you can actually see the source code. For instance, for Fanscoin, you can see the original source code that has been verified. It's actually a pretty new feature that you can verify the smart contract code. So I think if you go to contract registration, you can also upload your source code if you want to open source it, and it will verify it for you. Personally, I haven't tried this feature yet because I think it was just rolled out this week. This is very new. So that's basically the intro to Conflux Scan, and Conflux Port and Conflux Scan again are some of the fundamental tools that we use to interact with the Conflux blockchain. Okay, so now let's move on and see how you can get started with developing some dApps on Conflux. So again, our go-to reference should be this developer portal, and it actually has a bunch of very good guides. For instance, sending your first transaction, debugging transactions if your transaction seems to be stuck, and it also has the developer resources here. So usually, if you want to develop an application, you need a node that you can use to interact with the blockchain. Ideally, when you have a production application, you should use your own node, although that's usually not the case even for other blockchains. But for testing, we have some open endpoints that you can use here. So you can just go to this public RPCs page, and you can use some of these endpoints. And we have some services similar to Infura being developed for Conflux. So those might also be available to you if you need some nodes to interact with the blockchain. If you go to SDKs, you can see a lot of links to different programming language SDKs. So we have JavaScript, we have Go, Java, and Python. These are the 4 officially supported languages now. As for me, I usually use the JavaScript SDK because it's very good for prototyping and quick, playing around with some contracts. And yeah, you can just install it through npm. We will see some examples for this later. And then on this page, you see a bunch of different examples for different languages. There's more or less feature parity between most of these SDKs, so you can use all the features of Conflux. All right. So next up, I'd like to show you some examples of how you would develop on Conflux. And if you've developed on Ethereum, it's going to be very familiar to you. I'm going to use a tool called Conflux Truffle. Yeah, hopefully you can see my screen. Let me check if there's any questions so far. Right. So you can use this Truffle tool. That's basically, I think it's the most widely used Ethereum development framework. And there's a fork called Conflux Truffle, which is essentially the same. It just has some Conflux specific features. If you navigate to the npm site, for instance, or on GitHub, you can see the detailed documentation. So first of all, to install Conflux Truffle, you just use npm to install this global executable called Conflux Truffle. And somewhat counterintuitively, the executable is not called Conflux Truffle, it's called CFX Truffle. You can use the same commands as with the original Truffle. So init to create a new project, you can compile using the compile command. You can test, etc. So here I have an example project prepared for you. You can create a project like this with this structure using CFX Truffle init, and it will create a bunch of contracts, migrations, that kind of stuff for you. So first of all, let's look at this config. The configuration basically defines the networks that you can interact with. And I don't know if this is officially recommended, but the way I develop with Conflux Truffle is that I kind of mix together Ethereum stuff and Conflux stuff. So for instance, this Ganache is very, very useful tool, I think, for quick testing. So I actually have a network for that defined here in my config file. And I also have a local Conflux environment defined, which you can use Docker to run a local node. That's probably the easiest choice. And I also have the testnet set up here. Yeah, I use this public RPC endpoint that I just showed you now. And there's a bunch of other config things that you can actually check the official documentation of Truffle to see all the options. I usually don't need to touch most of these. Yeah, so that's the config file. And then the example I'd like to show you is how to interact with tokens. So I have this, let's say, my NFT receiver smart contract prepared for you. And again, you can see that I use the Open Zeppelin contracts here. If you interacted with Ethereum, you've likely come across Open Zeppelin. It's a smart contract library that you can use a lot of common smart contract patterns and interfaces and that kind of stuff. And the cool thing about Conflux being EVM compatible is that for many things, you can directly use the Ethereum implementation. For instance, if I want to interact with NFTs, ERC721 tokens, then I can just directly use the Open Zeppelin implementation if I don't want to re-implement it myself. Yeah, unfortunately, this is not always the case. So I've come across, I think, ERC777, the token standard. It uses some hard-coded global constants, the token registry contract, which is a different address. I believe it's a different address on Conflux. So you might actually need to change the Open Zeppelin code to change that address. But you can see that that's basically a question of some constants being defined in a different way. So it's not inherent to the virtual machine. So this example that I have here should be very easy to understand if you've worked with Solidity before. So this basically defines a contract. I called it my NFT receiver. And yeah, there's two parts. The first part is just to receive CFX. So you can define this receive interface, or you can use the fallback function that you might be familiar with. And this gets called when you don't call any contract methods, but you just send tokens to the contract. On Ethereum, it's the ETH token, and on Conflux is the CFX token. And every time I receive some tokens, all I do is that I emit an event. So that's very simple. Another thing that I like to be able to receive is NFTs. So the ERC721 token standard actually defines this interface called on ERC721 received, which is supposed to be called when you use the safe transfer from method of this NFT standard. So basically, we can react to NFTs being sent to this contract. And in this case, I like to emit an event that signifies that an NFT has been sent to this contract. So of course, this is a very toy example, because first of all, it just keeps the CFX and the NFT in the contract forever. They are locked there, so it's not very useful. Of course, ideally, if you want to create any, let's say, DeFi application, some liquidity farming or that kind of stuff, or some combination of fungible and non-fungible tokens, then you would use these interfaces and you would combine them with your own application logic. So we're very excited to actually see you come up with some ideas. Again, our hackathon bounty is about stable coins. But if you have other ideas that you'd like to explore on Conflux, you can always just reach out to us. We have a grants program and that kind of stuff. Yeah, so going back to Solidity, this should be very familiar to you if you've written Solidity code before. Yeah, and if I want to test this, I will also need an NFT contract. So I will need a contract from which I can send tokens to this other contract. So, and that should be very easy to define, because I can just directly use the OpenZeppelin preset. They have a very useful preset for a very simple NFT. And my NFT basically just uses this preset with some the token name, token symbol, and the token URI prefix. So this is all it takes to implement an NFT on Ethereum and Conflux alike. So one way to interact with your contracts is through the utilities that Conflux Truffle, or the original Truffle, provides. So these are the ones that I usually use in the tests. So when you write smart contract tests, you usually use these. When you write artifact require, it actually, so artifact require actually gives you the ABI and the bytecode of the contract that you compiled. And then when you call, let's say, contract new or contract deployed, it gives you this object that you can use to actually interact with the contract. So this object has the address, and you can actually call methods on this object, and that will execute on the blockchain, either your private local blockchain or the testnet. I'm not sure if you want to use it on the mainnet, but we will use it for testing here. Okay, and as I said, on this object, you can actually call the methods. Let's say this is my NFT contract, right? So I can just call the mint method. I will mint one NFT token to Alice, and I will call it from Alice because Alice is the admin anyway. And I will actually just make sure that this token number 0 belongs to Alice. So I will call this owner of method. So that is the NFT functionality. And actually, once I have the NFT, I can transfer it from Alice to this my NFT receiver token. Sorry, this my NFT receiver contract. So I will use the same safe transfer from method from this NFT contract to send token number 0 to this contract. And at the end, I will make sure that, okay, the new owner of this token is this recipient address. So again, this is a toy example, but I think it's a good example to show you how you can deploy contracts for testing, and how contracts can interact with each other, even though there's nothing new in this in terms of Conflux. If anything is unclear to you, you can always refer to the existing documentations of Solidity, of Truffle, or the relevant Conflux resources, which are very similar. Okay, let's say I have these contracts and let's say I have these tests. Now, how do I run these tests? How do I interact with the contracts? First of all, you will need to compile the contract. So I will use CFX Truffle compile, and this will automatically compile all the smart contracts available in this project. So in this case, we have 2 smart contracts so far. And after that, before I could actually interact with the contracts, I need to make sure that there's a migration. So for Truffle, migrations are these processes of deploying and updating the contracts. So I have a very simple migration here, which is just deploying the NFT contract and deploying the NFT receiver contract. Okay, so I could compile with Conflux Truffle. And for simplicity, for testing, I will just use Truffle instead of Conflux Truffle. Now, the more convenient thing about Truffle is that every time you run test, it actually starts a new test environment. You don't need to use Docker by yourself. If you use Conflux, you should actually use the... Oh, sorry. I hope you can hear me well. Someone is saying that the connection is poor. Let me know if you can't hear me, and I see if I can do anything. But hopefully it's all good for most of you by now. So if you go to, again, the Conflux Truffle tutorial, there's this thing called, I will go to this how to use, I will go to repository here. And there's this thing called the ultimate tutorial. I'll just go to Conflux Truffle. And here there's this ultimate guide, which actually walks you through just the whole process of using Conflux Truffle. And for instance, if you want to set up a local Conflux node for testing, you can just directly pull this Docker image and then just run it. But for me, for simplicity, I will just use the Ethereum testing because the smart contract behavior is the same on Conflux and Ethereum so far. So I can just use this. Okay, so that's smart contract testing. That's the first way to interact with contracts. And the other way to interact is to use scripts if you want to implement some special behavior, let's say. So here I have a script called mint and transfer. And this will, as the name suggests, it will mint a token and it will transfer the token from one address to the other. It basically does the same thing as the test. But I will just show you this so that you can see that it's not just for testing. You can actually use these utilities to interact with contracts on the testnet, for instance. So if you want to use accounts, let's say the testnet account on Conflux, you will need to use the CFX get accounts. So it will give you the available accounts on the actual network that you're using. I will just call this account Alice. And similarly to before, I will call the mint API from Alice. I will get the token ID, and then I will call the safe transfer from to transfer it from Alice to the recipient address. Now, what I'd like to show you with this script is how you can, instead of running on an Ethereum local node, how can you deploy these contracts and run these contracts on the Conflux testnet. So as you saw before, in the Truffle config, I have a Conflux testnet configuration. And of course, if you want to interact with the testnet, you will need some test CFX. So the easiest way to get started is to define your private key. So you can have some test accounts. Let's say I can go to Conflux portal, which is our wallet, as I mentioned. And I'd like to use this account 1 as the deployer account. So what I can do here is that I will go to details, and I'd like to export the private key. So this is, of course, this is just a throwaway test account for me. So normally you should not show your private key to anyone. But for now, I can just copy it here, and I can import this private key through this environment variable. So I just put my private key here. And when I work on the Conflux testnet, it will just directly use this private key to sign my transactions. So instead of sending the transactions from Conflux portal, I will send it from Conflux Truffle. All right, let's see if it works. So I can say Conflux Truffle. I want to specify the Conflux testnet as a network. And first of all, I will need to migrate, so to deploy all the contracts, run the migrations on the Conflux testnet. So behind the scenes, what it does is actually, if we go through these migrations, and when you say this deploy utility from Truffle, it will actually create a transaction with the bytecode of the contract. It will sign the transaction with my private key, and it will send the transaction through this endpoint into the testnet, and the rest, yeah. So here I already deployed these contracts before, but if this is not the case, then you can just see all the deployment output here. Yeah. So now it's already deployed. So let's see if I can run. Let me see if I can redeploy so that we can see the whole process. So even though my contracts are already deployed on the testnet, I will just reset and I will do a brand new deployment. So it might take a few moments. And yeah, hopefully by now the connection should be better. As you might see, we have some restrictions from here. Yeah, so this is basically the output. As you see, again, it should be familiar if you used Truffle before. We use the Conflux testnet network. And first of all, we need to deploy this migration contract. This is kind of internal for Truffle use. And you can see that we use some Conflux addresses. So this is the contract address. And this is the account that's used to deploy, I believe, the contract. And you can see all the different data. For instance, the number of CFX you had to spend to deploy this contract. So if I go back to my account, you can see that actually I had to, so my balance has changed, right? So I had to pay some CFX to execute these transactions. The second contract that I like to deploy is the NFT contract. So if you wait for a few seconds for the necessary confirmations, and the third contract is going to be the NFT receiver contract. So by the way, you might see that there's different formats for Conflux addresses. So some addresses have this type contract or type user in the middle, and some addresses do not. So that's intentionally how we define this address standard. So this part is optional, but this makes it easier for the users to differentiate between contracts and users. So when you use an address like this and let's say send a transaction, then the node will actually see whether it's a contract or not. And if you mistyped, if you wanted to interact with the contract, but instead of that you send a transaction to a user, then it will reject this transaction. So this just gives you some additional information. Okay, we deployed all these smart contracts. And as a second step, I'd like to execute this, what's it called, mint and transfer script. So you can use CFX Truffle. Again, I will use the Conflux testnet. And I just like to execute this script. So this Truffle execute basically just makes a lot of useful global variables available to you. Let's say the artifacts global and that kind of stuff. Again, what this script does is that, again, it uses the private key that I imported from Conflux portal, and it uses that to mint an NFT to my address, and then to transfer this NFT from the NFT, or let's say from my address to that other contract, the NFT receiver. Okay, so it prints the NFT contract address. It should be the same as on the Truffle output above. We can see the address of the other contract. And the first step, we're minting a new NFT to this address, the new NFT, and then we're transferring it from one address to to this contract address, and after that, the new owner of the NFT is this contract. So you can see that this again is a very simple example. It's just the basic, but you can use the existing developer tools. Let's say Truffle, which is same For instance, you can implement an NFT with this just a few lines of code using Open Zeppelin. So it's very easy to get started with Conflux. Okay, I'm glad to hear that the connection is better now.
It was a little bad,
but that I'd like to show you is another way to interact with Conflux, and it's an IDE development environment called Conflux Studio. So let me just try to, I will open it here. So Conflux Studio is an IDE. If you use Remix for Ethereum, it's kind of similar to Remix, although it has a different user experience. I think it's more personally to me, not by the device. And to use it, you can just navigate to release this page.
Hey, Peter, we can't see your screen.
When you open Conflux Studio, you will see a screen like this. First, for your Docker.
Peter, we can't see your screen. Do you mind sharing your screen again?
Run and then so I can actually if convenient and can just take the output here. It's actually, I think I ran it before, so it's actually fetching the Solidity compiler, and then it will compile the contract. Yeah, anyway, this time I couldn't, I think I have some connection issues, but you get the point. Okay, and if you compile the contract, you can use this deployment button to choose which contract to deploy, let's say my NFT, and then choose the deployer account and to deploy to the network. You can use a local development network in Docker, or you can use the testnet, or you can even interact with the mainnet if you want to. So here I chose the testnet. Now to maintain your identity, in the corner you go to this key icon. These are your identities you can use. So if I create actually create a private key for me on the mainnet. And if I copy this address, let's have a copy. Yeah, I will copy Bob. Next to the network page, there's this Explore page where I can actually check accounts. Let's say I search for this Bob account. What I should see. Okay, open tab. I'd see some information about this test account that was just created. Not surprisingly, there's no transactions, there's no balance, but I can use this faucet here to actually get some test CFX. So you can see that Conflux Studio provides many of the same functionalities as before, but it's just very convenient. You can deploy contracts and the same interface. And here I can also, if I click this FT contract address, I can use contract panel to open this contract and try to interact with it. I need to select which API I want to use. And you can see that there's a very convenient interface to mint tokens, to call these view interfaces. For instance, if I use the owner of interface, let's say token 0, ideally I should be able to get to reach this token. This is a very eminent development environment. I encourage you to check it out. But if you want to do anything advanced, of you truffle directly.
Peter, for the last couple of minutes, we couldn't see your screen.
And it's my keywords about transaction sponsorship. I'll go to the development portal, contracts. So you can read about sponsorship here. Again, it means that you can cover the transaction fees of your users. And this basically happens through a special smart contract interface. So this is an internal functionality of the Conflux network, but this is exposed as if it was were smart contracts, because right there, and if you see ABI here, then you can see the interface of this. Actually, I can just open it here because I copied it here. Sponsor whitelist control. So you can see the interface here. The way it works is there's a two-step process. The first step is that you need a certain number of tokens. This set sponsor for gas. You see the table function, so you can send 1,000 tokens to this contract, and you can set the sponsor transactions to this FB account up to this many. Yeah. And after this, all whitelisted who send transactions to this address will do it for free, as long as there's a balance, sponsor balance. So again, first step for you as a sponsor is that you call this method on this internal contract, and you send some funds that will be used for sponsorship. And the second step is that the contracts need to have certain addresses. So this is, you might want to actually whitelist users, some specific users, or you might want to whitelist all users. So the way you do this, for Solidity code, you need to open this internal special address. So it's called sponsor whitelist control, and you will need to give it an array of addresses. So here we just pass one address, and you need to call this add privilege method to say that I want to whitelist this account. Or alternatively, you can provide the 0 address here, and that means that you want to whitelist all the accounts, and all the accounts will be sponsored. Okay. So, more about documentation. Conflux.
Let's see. Peter, are you there?
I'm here, yeah. Can you hear me?
Okay. Yes. Unfortunately, like for the last couple of minutes, I couldn't see your screen. I don't know if everyone else couldn't see the screen, but I couldn't see your screen. So what I'm going to do is in the chat, I found a link to your Conflux 101, and it has a lot of the videos that you were talking about in there too. So hopefully that will be a good resource for anybody else who needs any further insight. But the first part of your presentation, I was able to catch it all. So it was really helpful and insightful. Let's see if anyone has any questions. Maybe you can take a quick question or let us know what's the best way to get in contact with you.
Yeah, sure. So if there are any questions, I think you can either ask now or ask any questions. We can just point you to the right resources on Discord or Telegram.
Perfect. And can you drop the link to the Discord in the chat so everyone has access to it? That would be helpful too.
Sure, I will do that in just a moment.
Okay, cool. And for those who are still here and want to join us, I know that the next session is going to start in just a moment, and that will be a session with Matt from MetaLux. So please feel free to join us in that session in just a moment. Get a drink and get refocused. Peter, I want to thank you so much for bearing with us through all of the different technical difficulties that they were having, but I found your presentation to be really, really informative. And I appreciate it that you were able to go through it in such a concise way, and that you're open for us reaching out if we needed to. Thank you also for staying up so late. I know it's late in China, so thank you for staying up so late.
It's my pleasure. Thanks for all of you for joining, and I'm looking forward to your submissions to the hackathon.
Yeah, for sure. All right, everyone, thank you so much, and we'll see you next time.